But there's one little thing with these, is that for these equations to work, this ball 2, always has to be at rest. It can't be moving before.
So if it is moving or was moving,
So if you have this kind of a case where they're both moving, what you do is you change your reference frame. And it kind of talks about that right here. So you change your reference frame to figure all that out. But as far as this class is concerned, you don't really have to do that. So you don't have to alter your reference frame in order to solve it. So you'll just be given problems like this where ball 1 is moving and ball 2 is not. But you can read about it if you want to and figure out what kind of, like how to solve those kinds of problems. Okay? But for now, these are the equations. So if it says it's a perfectly inelastic collision, you'll just use conservation of momentum. If it says it's a perfectly elastic collision, then you'll use these two equations. Okay?
so if you use the first one and find out the original velocity of the first one, wait, no, that's the final velocity of the first one. Can you just use that rather than the second equation to find out the second one?
No, because they're not directly related. So this is the initial velocity of x. So the way you plug this in, let me show you here. So this would be your problem. It would say you've got a pool ball mass of 0.25 kilograms moving this way at 10 meters per second. It strikes something larger that's at rest, and it has a mass of 1.5 kilograms. Okay? So that would be the problem. Say you have a ball, it comes and runs into another ball, and there's a perfectly elastic collision. Find out what the speeds are after. So how do we find the speed of the first ball afterwards?
We take its mass, 0.25 minus 1.5 over 1.5 plus 1.5 times 10.
Okay, 0.25 minus 1.5, that's negative 1.25. Right? All over 0.25 plus 1.5, which is 1.75. So it's a negative number. It would be negative 1.25 over 1.75 times 10, and that is 5 over 7 times 10, 50 over 7. It's about 7.14 something.
Negative?
Yeah, negative. Is that right?
That sounds right.
Seems about right. 1.25. Yeah, 7.142. Okay? So that means after the collision, this ball,
How did you know the 1.42 part?
so you have 5 over 7 So you have 50 over 7. The nearest to 50 is 49. So that's 7 times 7. So that's 7. And then you have 1 left over. So that's basically 10, right? If you move 1 place over, that means you have 10 left over. So that means you have 1 7 can go into 10. That leaves 0.3. So you move 1 over, and that means you have 30. How many times does 7 go into 30?
4.
Right. So that'll be 4. That leaves 2. You move over 1 place, you have 20. How many times does 7 go into 20?
2.
2. That'll leave 6. You move over 1 place, then you have 60. The next decimal is at 8, because 7 times 8 is 56. And it'd be a 5, and then it'll repeat itself. Okay. So as long as it's a simple number in the denominator, you can do it pretty quick. Yeah. Okay. So what's the velocity final of ball 2?
0.5 over 1.75.
Times 10. So this one would be positive. So what is that? 2 over 7? So 20 over 7. So 2.8. 5. 7. 1, 4. 2, 8. 5, 7, 1. As you keep going like that. And so that means this big ball will roll away at 2.857 meters per second. So using these two equations, you're able to solve for both velocities. Whereas with momentum, you wouldn't be able to do that. Okay?